So we make buildings smart. So this is a little story about what Nuuka does. I'm Mikko, I'm the CEO of the company. And I think this should now work, right? Okay. So like it said in the title, our job is to make buildings smart. And how do we do that is by managing the big data that flows inside the buildings. And why is that important? It's important because you can save a lot of costs, you can be much more sustainable, and at the end of the day you can get happier tenants and increase the property value of your properties, of your real estate. A typical situation in today's, especially a little bit more modern buildings, is that you have all of these different sensor data coming into the buildings. You have the building automation systems, you have the energy metering, different kind of energy efficiency projects and so on. There's actually quite a bit of data flowing around in buildings like this. It can be 5,000 data points, but it can be 100,000 data points in a big office building or big hospital, for example. What Nuuka does is that we collect, aggregate, analyze, and then use that data with our algorithms to better manage that building. And by better managing that building, obviously then saving cost and being more efficient. So a typical situation in a building today is that you have different formats, you have different data sources, and then you have very different needs for that kind of information. So you might be an energy expert who needs the information for energy efficiency projects. You might be an asset manager who wants to know, is my building performing optimally? What are my running costs of the building, my operational costs, how can I save those? And all of these different users today have different ways of using the data, and the most importantly, they don't really get really good access to that data these days. So that's where we come in. So the different shareholders in these buildings and in this whole real estate industry need the information, but in a little bit different format. And it's pretty obvious that the low-hanging fruit has been energy efficiency. So a typical situation might be that you have, let's say in a building like this, I would assume 20 air conditioning units maybe, energy meters in probably all of the rooms, maybe some indoor air sensors. And then when you look at all of that data together, and you might find out, which is actually very typical, is that there's a cooling device on in this room, and on that room on that side, somebody's putting more heat on, which, as you can imagine, is not very efficient. So what you can do with our software is you can optimize the usage of the building, saving energy, but also having a very good indoor air quality at the same time. So what typically happens these days is that when you talk to, let's say, an energy efficiency consultant, for example, in building industry, is that they come in and say, let's change your light bulbs into LED. Well, great. That's one way of saving energy. We are all for that. Or another example is that if you go to schools or public buildings, they say, well, there's people are here, the students are here from 8 o'clock until 6 o'clock in the evening. Let's turn off the air conditioning after that for the whole night. Well, what that means is that you have now optimized your energy. You probably have saved, let's say, 30%, but then you have a mold issue after 2 years. So the moist doesn't get out of the building, the indoor air quality is bad, and things like that. So what we do is we don't only sub-optimize one part of the building, but we take all the data in for a building and optimize the whole building as a whole. Another point of view for this is that if you are a real estate investor these days, and if you want to raise funds for a real estate fund, let's say in London or Amsterdam or Frankfurt or Stockholm, typically the big pension funds ask you, how are you doing in terms of sustainability? Are your buildings using any renewable energy sources? Are you taking care of your waste and things like that? And there are actually global measurements of how to analyze and how to benchmark your sustainability in terms of buildings and real estate industry. That is one very important way of reporting the big data that flows inside the buildings. One more example of this is that there's now legislation coming in Amsterdam or in the Netherlands. As you know, in all of the dishwashers, for example, you have the energy rating from A, B, C, D, and I don't know how long they go, but I have a B- back home. What the legislation says in the Netherlands is that if you want to use, or if you want to pension funds or any financial institutions that has anything to do with the government, they are not going to finance any projects in real estate if the energy rating is worse than C, starting from 2020. Now imagine if you are a real estate owner and you have 100 buildings in the Netherlands, and maybe 20 of them are A, and 80 of them energy rating, you don't know what it is. And then you want to sell them off, and after 2020, no financial institution will finance them because they are not energy efficient enough. So these type of things is why you need to understand what's going on inside your buildings. And what we have done in our business is that typically these type of things are done through what we call the basement experts or the real engineers. And they look at user interfaces like the one on the left, which is a kind of a traditional building automation user interface. And as you can imagine, not a lot of, I mean, let's just say I would not be able to do anything with that. I'm not an engineer and I don't want to be. But what I could do is I could look into the other picture and say, okay, now Nuuka has modeled that building automation, that building big data into something that I can understand. Now I can read where my energy is consumed, what my indoor air quality is, and how I can improve things. So we take that, we bring something modern to the building industry that is not always so modern. So basically the value proposition is that we increase the property value. So we increase it by lower energy cost, happier tenants, and reducing the management burden. And this is the kind of the value promise for the building owners and also for the maintenance companies who are one of our bigger customers. But let me tell you something about the market that we are in. So we've estimated that today in the European Union area alone, there's roughly 20 million commercially managed buildings. Out of those, roughly 10 million buildings are actively managed, so they're part of an active portfolio. Somebody's actually trying to do something with them. And our sweet spot today is the 7.5 million buildings that are actively managed and a part of a larger portfolio. So it's actual investor or a big user like, let's say, ICA here in Sweden that is actively using those buildings. What I think is very important in terms of market growth is to understand is that obviously we want to gain ground by selling more, adding more buildings, the typical stuff. But what is very important to understand is that when we have started this business roughly 3.5 years ago, a typical building would have 10, maybe 50, what we call data points. So there's the building automation system, there might be some energy metering systems, there might be something else. Now all of a sudden, all the indoor air sensors, all the smart technology, all the IoT is coming into play, and we have the same building that we started 3 years ago with 25 data points, now has 2,500 data points. Because all of a sudden the air conditioning unit starts sending data how it's working and how it's not working. And when we tap into every machine that sends data in that building process, that's how we are then optimizing the building to perform much more efficiently. We've been growing pretty well from last year. We started 2016 with 300 buildings under management. We today have 957 to be exact under management, and we are looking to expand the growth of buildings hopefully exponentially. If I would put our forecasting date, it wouldn't fit the screen, so I'm trying to be modest here. And where we are as a company is that the international rollout has really started. So I'm very proud to show you this picture. I mean, we are a small company from Finland, from Kotka of all places. And we now have customers, a major headquarter in New Jersey. It's actually just on the other side of Hudson River. I can't even pronounce the university name in Shanghai. Somebody told me how to pronounce it, but let's just say university in Shanghai. And then we have several of major office buildings especially in Finland, but we also just got our first deals in the Benelux. We have some projects going on here in Sweden. So it's the company is in really growth phase right now. What I thought that I would show you today is 3 examples of how our technology is used. I mean, I know that this can be pretty overwhelming overwhelming or hard to understand. I mean, I've joined the company 3 months ago, and somebody started talking to me about building big data. I was like, what is that? So I'm trying to show you in practical examples of how our software is used today. So, example, smart building concept. This is an example of a building called The Edge. This is a Deloitte head office in Amsterdam. It's built by our customer called OVG. OVG is the construction company that has built and also maintains this building, The Edge. The Edge has been selected as the most sustainable building in the world. As an example, it collects all the rainwater and put it in the circulation, and you can flush your toilet with the rainwater and all that kind of nice stuff. That is really important. So it's a very sustainable building. It's a real flagship product for all of the people in this industry. You would probably know the name. This building has 25,000 metering points and 25 different systems that the maintenance company and the owner of the building is supposed to look at to see how we are doing. So as an example, if you go into the building, they ask for your phone number. Then you put your phone back in your pocket and you walk to the elevators, and the elevator comes to you, and then it takes you to that floor that you are visiting, and there's no buttons in the elevator. And I asked them, how that is done, and they have some sort of a technology that I know nothing about that reads my phone and then takes me to the 17th floor because that's where my meeting is. So this is the kind of technology that they have in place. So what we do with them is that we consolidate those 25 different data solutions and put them in something that looks like this. So what they have here is that they are using their portfolio of roughly 100 buildings that they have built and now maintain, and they have scored them what they call a smart building score. So the smart building score for this specific building that is not The Edge but something else is 81. Then they said that the productivity has gained, has been increasing 4%. The tenants are happy or not happy, and there are different metrics on this. And what they use this for is that when they go to the Googles of the world or the Watti here on some other high-tech sustainable company who wants to rent a space from somebody, they go in and say, we have the smartest and the most sustainable buildings. See, we are reporting how it's doing. And that's why they've been able to get premium rents for the office spaces. For example, in Amsterdam, they are talking about roughly 10% premium compared to other office buildings. And that 10% is obviously quite a bit of money in the property investors' pockets. So that's one example. This is what we do. Another example that I think might be more concrete is that our software is used for what we call pleasant living and pleasant working conditions. So as an example, mögel, I think was the word in Swedish. I tried to learn that today. So the mold-free public building. So you all know these stories from the newspapers. This is a huge thing in Finland, especially for father of four like myself. I would like to know that my kids' schools and my kids' daycare places are mold-free and they don't get asthma when they are 7 years old. So what we have done together with our customer called Lemminkäinen in Finland is that they built a wooden daycare place. We helped them design the technology inside there. So they have indoor air sensors in every room. They actually have a lot of other sensors as well. Then they also detect chemicals and stuff like that inside the daycare places. And then we provide an app that shows when my kids go to the daycare place, it shows if the indoor air quality is good or bad. Now, if it's not good, then I obviously can hopefully talk to somebody, and rather than say that my 4-year-old has a flu, I can actually say that maybe it's because the indoor air quality is bad. And if it's good, I'm just happy. So these are so from our perspective, exactly the same technology, but just another application of the same technology. One more example that I'd like to show is kind of our sustainable demand response solution. Now I don't know how much in a detail, because I don't know exactly what your background is in this, but I try to explain a little bit about the concept and then you can ask questions afterwards. So as you probably know, you look at this picture and you see the red line is the typical electricity consumption of an office building or a household during one day. So in the middle of the night, there's no peaks. At 8 o'clock or 7 o'clock when we wake up and put on our coffee machine and take a shower and so on, the energy demand is much higher. We go to school, we go to work and so on, so nobody's at home, it's not as high. Then we come back at 3 o'clock, 4 o'clock, 5 o'clock, whatever, and again it's high, and then it goes down when everybody goes to sleep. Very typical electricity consumption of a public building or home. That's the normal curve. So then there's a consumption curve with demand response management. So there's some sort of a technology to take away those peaks. That's the green light, the green line. Why this is a problem is that typically the capacity of power plants is not 100% or not 110%, it's maybe 95. So those peak hours, typical example, January, Finland, Sweden, Saturday night, 6 o'clock, everybody goes to sauna and at the same time put their sauna on. Power companies don't like that at all, trust me. Why this is a problem for them is that they have a certain load that they can put to the grid, obviously. For example, here in Stockholm, I think it's roughly 90% renewables because you take so much hydro and all other good environmental renewable sources. But then that 10% that they need to put on that extra power plant just to meet those peaks, they don't get any more money from that, but they need to put on the fossil fuel, let's say the coal plant, on the oil boilers or whatever form of energy that nobody would like to use, but they need to use because we want to go to sauna at 6 o'clock in January on Saturdays. Now, if somebody comes up with a technology that can take away those peaks, there's a lot of benefits for the power companies, but there's also a lot of benefits for the, you might want to go back one more. There we go. So there's also a lot of benefits for the grid operators. So one of the biggest headaches of these Svenska Kraftnät and Fingrid and these grid operators is that they need to balance the grid load. It's not good if the grid load goes up and down all the time because it's gonna break the devices and creates a lot of other problems. So what we can do in this space is that since we have roughly 1,000 buildings under our control right now, we are connected to every air conditioning unit, every building automation system inside those buildings. When the peak hour comes, we could maybe not totally turn off the air conditioning unit, but maybe we put it on 20% or the heating for 20%. Nobody would notice that if we put it down for like 30 minutes, 60 minutes, 2 hours a day. And at the same time supervise that the indoor air quality stays good. These type of solutions, there's a lot of different technologies for demand response, but we have the feeling that the connecting this with the building industry is not really what people are used to doing, and then also connecting that with good indoor air conditions is could be a really good breakthrough for us. And this is just to show you a picture of what it looks like in real time. So this is last day of March, an office building in Finland, a real-time figure from our software. You can see that the energy kilowatt hours consumed can change from 60, roughly 80 or so to 110. So there's a big variation. I mean, I'm not joking. There actually is a big variation in terms of how the energy is used. But just to give you a little bit of an examples of what we do and how our technology can be used. So, any good questions or comments?
Thank you very much, Mikko. Any questions for Mikko? Yes, please, right here. Yes.
There were no financial information in your presentation at all. I mean, we are in potential investors, and you have to explain to us why this is a good investment opportunity.
Didn't it show in the picture that was good?
No. I mean, you say 900 buildings.
Yes.
What is your income from these arrangements and so on and so
yes.
forth?
So it's a two things. So it's a fairly small company. Our last year revenue was 350,000 euros. Why the number of buildings figure I think is very important is that that's the basis for the monthly recurring revenue. We are a SaaS-based company, and the number of buildings correlate to the monthly revenue. So that's why that is important. That's why we always show that. Our business model in the past has been that we have been charging much more from the projects and less from the monthly. But now we are changing the model much more, a little bit towards what NSIs is doing. Also the shared saving model, and then also heavily on the SaaS price. So the monthly recurring revenue that we have forecasted that would be at the end of this year is roughly 450,000 euros on an annual basis. So recurring revenue. And on top of that, there's project fees of about the same size. So that's where we are with the numbers.
When do you come into the process? I mean, you are supervising metering points.
Mm-hmm.
But do you decide where there should be a metering point? Would you like to be involved in the construction of a office building that you would then continue to monitor?
Yes. So the ideal situation would be that we would be part of the design phase as well. So as an example, there's now in Kalasatama in Helsinki, one of the areas in Helsinki, they are building 5 skyscrapers, 5 big residential buildings. We are part of the design phase, and the reason for that is that in every apartment in that residential building, you have a little smart screen or what have you, which basically says that when you get out of the room, you can turn it. You can say that I'm out of this apartment, and then we automatically can lower the energy consumption, for example, in that particular apartment. Of course, that would not be possible if they wouldn't have the sensors in every apartment. So in that case, it would be very valuable for us to be, or it is very valuable for us to be in the take part in the design phase already. However, today, a lot of the sensors and the meters and so on, they are either Wi-Fi enabled, GSM enabled, or other technology that doesn't require wiring. So you can basically go into a room like this and start putting in, without drilling a hole to a wall, you can start putting in different type of sensors, and then have a Wi-Fi or some other protocol to send it to our cloud, and then we can start analyzing it. So we don't sell any sensors or any hardware or any metering or anything like that. We are a software company. We are data analytics, big data analytics company. But we obviously can recommend that this is a good sensor, or that is a good gateway, or this is what you should take. And we are part of that, or we do that quite a bit. But that's just to get the data that we need so that we can manage the building better.
Right, another question here. Go ahead.
Thank you very much. Smart home niche is still evaluated as an emerging ecosystem, and there are plenty of applications related with hardware, software, sensors, IoT, etc. in smart home energy management business.
Mm-hmm.
How do you differentiate your solution comparing with the others? Because it's really hard to say that some of them managed to survive and beat the market.
Yes.
Out of it. How would you target it in your position?
Well, good question, because this is what always comes up, and I think I have a good answer. So we provide a big data platform that has a lot of analytics and BI tools that you can basically create whatever report you want out of that data, whatever you use it more or less whatever you need as a building owner and maintenance company. How we are and why we say that we are a platform provider is that, let's say 3 years ago, everybody was talking about energy efficiency of buildings. 2 years ago or a year ago, it was all about indoor air quality because of the mold issues. Now there's a lot of talk about the wellness of the chemicals in the air and the wellness of the indoor air, and because we spend 80% of our time indoors and all these type of things. So my answer to this question would be that 3 years ago it was energy, 2 years ago it was indoor air, then it was sustainability, now it's wellness, and so on and so forth. Why would you, as an owner of a big portfolio, buy the point solution for energy, the point solution for indoor air, the point solution for sustainability reporting, when you could get a platform that has 50 or so already made integration layers to all of these different sensors? We can put it in the platform, we can do analytics on that, and then if it's next year, if it's the whatever security issue that you want to now look at, or where people are, or you know, if people like the Starbucks coffee or the, you know, some other coffee from that machine, or whatever it is that you want to measure, we have that data. And then you can build from that data the application that you need. So that was kind of one of the reasons why I wanted to show you the indoor air app for, you know, for daycare, and then you know, demand and response solution for big power companies, is that the platform enables you to do different things when you have the data. So that's how we think we are different. So we think that the buildings, especially big portfolio of buildings, should be and could be managed as well as big manufacturing plants, that what Energize is doing. There's a lot of data in there. You can really play with the data and actually optimize the building without any hardware investments. And in terms of energy, our portfolio consumes, the buildings that we have in under our management, they consume a lot of energy that is comparable to a lot of big factories. So if you could start monitoring, managing those like they would be a, you know, energy consuming factory, there's a lot of things you can gain from that.
Another question just behind. Yeah, go ahead.
Thank you. Yeah, now it works. I was thinking about the grid provider. Do you have any business model for charging them, or just blackmailing?
Yes. So yes, we do have a business model. Are we charging them at the moment? No. So how it works in the Nordics is that, as you probably know, the Nord Pool market is more or less all the same. So Finland and Sweden and Norway, we are all connected. Estonia, Latvia, Lithuania, we are all connected. The grid is connected everywhere. And as an anecdote here, by the way, do you know what is the single biggest factor for your energy price here in Stockholm? If it rains in northern parts of Norway or not. Because if it rains, there's a lot of hydro, which is cheap. If it doesn't rain, there's not a lot of hydro, and it's expensive. But that's another note. So the grid operators actually pay you as a solution provider to be on alert. So if you can say to the grid operator that we have, let's say, 500 gigawatt hours of electricity, and out of that in our portfolio consumed electricity, for example, that then can be managed so that we can lower the load or higher the load depending on what the grid needs, then they pay you to be on alert. Because when there then is a peak hour, they need these providers who they can call and say, you know, for the next 6 hours, can you lower the demand for 20% or things like that. So that's one business model. Another business model obviously would be to go to power companies and offer the same type of ideology for them. But it's an ongoing I can't say everything we do in that space, but we do kind of several different things.
Got a question over there?
Yeah. I wonder about your churn. I mean, how many clients do you lose per year, or buildings or so on?
Yes. So that's a great question, because I have an excellent answer. We haven't lost a customer since the start of the company. So out of those 950 or so buildings, it comes from roughly 35 customers at the moment. We have never lost a customer. What we have lost is the few of the buildings, because now there's a real estate fund who just sold 20 buildings. So that has happened for sure. But at the moment, we are proud to say that we haven't lost any customers. And how we do this is that we always start with, if you're a real estate owner with, let's say, 100 buildings, we go in and say, can we do a pilot for you for 3 buildings? If you like our solution, then this is what's going to cost for the 3 buildings, or 6 buildings, or 10 buildings, or 100 buildings. And that's how we usually get our sales. The problem with that model is that it takes some time, because now you have to do the pilot, get the results, and so on. So there are a lot of things that we can change in that as well, but that's what we've been doing.
Any more questions for Mikko? No? Well, great. I think that was a great session.
Thank
I won't
you.
add any to it. Thank you very much.
Thank you.